Okay, Assalamualaikum and hello everyone. So now we are doing chapter summary for 7.1 until 7.3 as we have a very long chapter 7, so we'll do it part by part. Okay, for 7.1 we have kinematics of simple harmonic motion. Okay, so basically for this subtopic, we are looking at the equation for simple harmonic motion. So we start with simple harmonic motion equation, that is equation for displacement. It is equal to A sine omega t, and hopefully you still can recall the equation for omega, that is 2 pi f or 2 pi over period. Okay, so apart from the displacement, you also have the equation for velocity. But for velocity, we have the equation for velocity in terms of time, and also the equation for velocity in terms of displacement. So for time, we have A omega cos omega t. For displacement, we have V is equal to plus minus omega square root a squared minus y squared. Okay, so that is for velocity. The equation for acceleration, so A in terms of time is negative omega squared A sine omega t, and also A in terms of displacement, it is equal to negative omega squared y. Okay, so the basic kinematics equation for simple harmonic motion. And apart from that, we also have the equation for the energy. Okay, so we have the energy for potential energy is half k y squared, and kinetic energy we have half k a squared minus y squared. Okay, and last one is we have the total energy is E is half k a squared. And please remember that our k is the spring constant, can also be written as m omega squared. Okay, so we have quite a lot of equation here. Okay, so then we proceed with 7.2. Basically 7.2 is about graph of simple harmonic motion. So this graph that we're going to plot or to sketch is based on the equation that we have got from 7.1 here. Okay, so we are going to have the graph of displacement, okay, y against t, the graph of velocity, v against t, the graph of acceleration, a against t. So all of these graphs are depending on the equation of the simple harmonic motion. So for example, we have graph of displacement is a sine omega t. So it is a normal graph of sine graph. So the form of the sine graph is like this. So when you are plotting the graph, the most important part is you should have your label, your axis labeled with unit, and also you have to label the amplitude and the period. So that are the most important parts that are needed when you plot a graph. And also for the velocity, the equation for velocity is this one, A omega cos omega t. So it is a cosine graph. The form of the cosine graph is like this. Okay, so again you need to label the unit, okay, the unit, the period. If you get the value, you just put the value here, and the maximum value of velocity, A omega. Okay, and for the acceleration, we have this equation. So it's negative sine graph. So the form of negative sine graph is like this, and again we need to label the unit, meter per second squared, the unit for the axis labeled, the maximum value negative A omega squared, and the period. Okay, so that is how you label the graph of A against T, Y against T, and also V against T. Okay, so apart from that, you also have the graph of energy against Y. So on one axis, we can draw three graphs. So energy against Y. So those three graphs are, for the first one is the graph of potential energy. So you have to label the graph for kinetic energy, and the third one is the graph for total energy. Okay, so this is the graph for total energy. So on one axis, you are having three forms of graph. And last one is 7.3 is the period of simple harmonic motion. So we have the period for the case of the first one is simple pendulum. Okay, and the equation is T is equal to 2 pi square root L over G. And the second one is mass spring system. And the equation is T is equal to 2 pi square root M over K. So if you refer to these two equations, it is what are we trying to understand here is that our period of simple pendulum, period of oscillation, is depending on L, and it is not depending on mass of the pendulum bob or any object that is oscillating. But for the mass spring system, the period is depending on the mass. So that's all for the chapter summary for 7.1 and 7.1 until 7.3. And for the next session, we'll continue 7.4 until 7.9. Thank you.